Okay, to graph it, we're going to use a table of values. The x values have been given to you. Okay, they've given you x values starting at -3 and going up to +3. And then, of course, you already know the function is y equals x squared. So, to figure out the corresponding y value for each given x value, what do you do? Correct. So when you plug in a -3 and you square it, it gives you a +9. When you plug in a -2 and square it, it gives you a 4. When you plug in a -1 and square it, you get a 0 squared, 1 squared, 2 squared, and 3 squared. Now remind me again why it is that no matter if we plug in a -3 or a +3, we still end up with a +9. Why is that? Correct. Since you're squaring them, it doesn't really matter that it's a -3, because when you square a -3, the negatives cancel each other out, because a negative times a negative is a positive. Okay, now we're going to put these points on the graph so that we can see what the parent function looks like. Left 3, up 9. This would be left 2, up 4. -1, 1 would be left 1, up 1. 0, 0 is just at the origin. 1, 1 is right 1, up 1. 2, 4 is right 2, up 4. And 3, 9 is right 3, up 9. Then it makes a U-shaped graph called a parabola. Now, even though it's not a perfectly U-shaped graph, it's definitely not a V, because with a V, you would need two perfectly straight lines. And this point are not the same slope, so it would not make a straight line. Okay, so it's more of a U-shaped graph. And this is called the parent function of quadratic functions. Now what we're going to do is we are going to, sorry, don't write that down there because we're going to write other stuff. That was like a review with my other class. We are going to use our calculator a lot today. So if you don't have a calculator, you need to get up now and get one, because we're going to be using it the entire class. The first thing you're going to do to graph all three of these equations is on your calculator. We're going to, well, before we do it, let's clear the calculators, because last period we were graphing a lot of stuff, and so for it to be a fresh start for y'all, let's clear it by hitting second plus sign 712. Okay, then now we're ready to graph. So you're going to go to y equals, and then in y1, I'm going to type in that first equation, which says x squared. To type in the x, it's right here under the mode button. And then to square it, see over here right above the button that says log, it says x squared. Okay, so is everybody comfortable with typing in the x and typing in the squared? Now you're going to go down to y2, and you're going to type in x squared plus 3. So x squared plus 3. And then you're going to go down to y3, and you're going to type in x squared plus 7. Okay, now you can go ahead and hit graph, and I'm about to hit graph, and if I were you, I would watch it up on my screen because my calculator is in color. So it's more obvious which one is which. Like the x squared, the parent function, is going to be graphed in blue. The x squared plus 3 is going to be graphed in red. And the x squared plus 7 is going to be in black. Okay, so I'm about to hit graph if you want to watch it. And it's pretty slow. Okay, here comes y equals x squared, the parent function. And then here comes y equals x squared plus 3. And then here comes y equals x squared plus 7. Okay, so what happened? Okay, it kind of does appear to be skinnier, right? But it's really not. The reason it appears to is because you can just see less of it on the screen. It's just moving up. Like this one, instead of starting at 0, it started at 3 because of that plus 3 in the equation. This one started at 7 because of that plus 7. Now, some of you may not be convinced that they're the same size. Some of you still may think, no, they're smaller than each other. I'm going to prove to you that they're the same size. You don't have to do this, just watch. See how, like, this is called a window. What you're looking at is called the window. And see how on the window you can go up 10 on the y-axis, down 10, right 10, and left 10? Well, say that I wanted to see up farther on the y-axis. I could go to my window, and then up the y-axis would be the y-max. So instead of going up 10, I'm going to go up 50. Or no, I'm going to just go all the way up 100. Okay, so up 100 notches on the y-axis. See how it did 100 notches? Okay, now here's my parent function, y equals x squared. It started at 0, 0. There comes the y equals x squared plus 3, starting a teeny bit higher, 3 units higher. And then here comes y equals x squared plus 7. Now are you convinced that they're all the same size and they just have different starting points on the y-axis? Okay, so over here in this block, you are going to write, and I'm just going to draw arrows, the x squared plus 3 causes the vertex to shift up 3. The vertex shifts up 3 units. Okay, y equals x squared plus 7 causes the vertex to shift up 7 units. So if you want to save some time and don't write, just do these. And then you can just write 7 units. And that just means the vertex shifts up 7 units. Have you ever seen anybody do that before? You've never seen that? Yeah, like if something is written above and you're about to write the same thing, if you just put like little quotations, it means the same thing. It goes right here. Okay, so the conjecture is that the graph of y equals x squared plus a. So if you're adding a number onto the x squared, it will cause the parent graph to shift up a units. And in this case, a would be like whatever number they plug in right there. Okay, now let's look at the next page. Okay, let's use our common sense to save time. This time, you have your parent function, y equals x squared, and then you have y equals x squared minus 3 and x squared minus 7. So what do you think is going to happen because of the minus 3 and the minus 7? Right, the vertex will shift down 3 units. And then for x squared minus 7, the vertex will shift down 7 units. Okay, and while you're writing that, I'm going to quickly graph it just so you can see it, but you don't have to take the time to graph it. Okay, the equations are pretty much in there. All I'm having to do is change the plus sign to minuses on both of them. Okay, there's y equals x squared. That's the parent function. And then there's y equals x squared minus 3. The vertex just shifted down 3 units. And then there's y equals x squared minus 7. The vertex is now down 7 units from the origin. Okay? So the conjecture is that the graph of y equals x squared minus a will cause the parent graph to shift down a units. Yeah? I can turn it off. Okay. The next one, you're going to need to graph it. Okay, so go ahead and type those 3 in your calculator. Y equals x squared is already there from the first time we did it. and then you're going to type in y equals x squared, or x plus 3 in parentheses. Make sure you put those parentheses around x plus 3 just like they are. Okay, so now I've typed them in, y equals x squared, y equals x plus 3, all in parentheses squared, and then y equals x plus 7, all in parentheses squared. Now I'm going to graph them. The first one that's graphed is the parent function, the one that hasn't been moved at all. It's just a 0, 0. Then the next one you see does what? But which direction? To the left. Didn't that vertex of 0, 0 move left 3 units? And then the black one, the vertex moved left 7. Okay, so when you put plus 3 inside parentheses, it moves the vertex, I don't understand, will shift left 3 units, bless you. And then with x plus 7 in parentheses all squared, the vertex will shift left 7 units. Okay, so just quickly look up at the board for a second. If the number is not in parentheses, okay, if the number is not in parentheses, it's a vertical shift, either up and down. If it's plus, it's up. If it's minus, it's down. If the number is inside parentheses and the squared's on the outside, that's a horizontal shift. Plus 3 is left 3, so minus 3 will be right 3. Okay, but before we write that, let's go back up and do the conjecture here. The graph of y equals x plus a squared will cause the parent graph to shift left a units. Okay, so just what we were saying before, if x plus 3 squared caused it to go left, then x minus 3 squared will cause the vertex to shift right. Three units. And then x minus 7 all squared will cause the vertex to shift right 7 units. So the graph of y equals x minus a squared will cause the parent graph to shift right a units. Okay, now graph those three in your calculator. Y equals x squared, y equals negative x squared, and y equals negative 3x squared. Okay, I'm going to graph it on mine. Okay, the second one is y equals negative x squared. And then the third one is y equals negative 3x squared. Okay, remember the first one that graphs is the parent function. It's just y equals positive x squared. The second one that's about to graph is y equals negative x squared. So what's the difference? It reflected. And then the one that's about to graph is y equals negative 3x squared, which not only reflects because of the negative, but gets skinnier because of the 3. Okay, a vertical stretch. So the negative causes the parabola to reflect. And then with the negative 3x squared, the parabola reflects and stretches vertically. I'm just going to abbreviate vertically by a factor of 3. Okay, so the conjecture is multiplying the parent graph by a negative causes the parent graph to reflect. All right, now type in those 3 equations in your calculator. Okay, I'm about to graph them, so if you want to watch up here, you can. There's y equals x squared, the parent function. And then there's y equals 3x squared, which got a little bit skinnier because of that 3. And then y equals 7x squared gets even skinnier because 7 is bigger. Okay, the bigger the a value gets, the skinnier the parabola gets. Just like, don't do this, just watch. Remember with linear functions, the parent function for linear functions is just y equals x. Y equals mx plus b, but the parent function is just when it's 1x plus 0, so y equals x. And then what if I did y equals 3x, so the slope is now 3, and then y equals 7x, so the slope is now 7. Watch what will happen between these 3 lines. Okay, there's y equals x, the parent function, that's just a slope of 1. And then here comes y equals 3x, it's a slope of 3, and it's steeper, right? And then here comes y equals 7x with a slope of 7, which is even steeper. So when you change your m and the number gets bigger and bigger, the line gets steeper and steeper. With a parabola, the bigger the a value gets, the skinnier the parabola gets because it's more stretched out. Does that make sense to everybody? Okay, so on your paper, you will write that this one was a vertical stretch by a factor of 3. And then for this one, it was also a vertical stretch by a factor of 7. Yeah. And they'll call that a factor. Okay, so multiplying the parent graph by a number whose absolute value is greater than 1 causes the parent graph to stretch vertically. Okay, and the larger that number is, the skinnier the parabola gets, because the more stretched out it is. Okay, now when you're done writing that, go ahead and turn to page 6. Okay, y equals x squared, y equals 1/2 x squared, y equals 1/4 x squared. Let's go and graph those 3. And I'm just going to clear my calculator by doing second plus times 7, 1, 2, because I feel like that's faster than going in and deleting all that stuff that I had graphed. Second, well, but I had graphed all 3 lines too, so I had 6 equations in there. If you ever just want to clear it, all of it, you just do second plus sign 712. Plus. No, right here, plus. Okay. Well, plus sign is the same thing. Yep, the plus. Okay, so now y equals x squared is the first one. The second equation is y equals 1/2 x squared. You can do alpha y equals n over d to type that in, or you could simply do 1 divided by 2 and then x squared. And then for 1/4, you can just do 1/4. Or if you want to, because you're used to typing in the fraction thing, you can use alpha y equals n over d, whatever you want. Okay, so remember, with the parent function, the number out in front of this x squared is a 1. So now the a value is a 1/2, and now the a value is a 1/4, which is smaller, right? This is the smallest number, and then that's the next smallest, and then of course 1 is the largest. So when I graph them, whenever it's just y equals 1x squared, the parent function, it looks like that. That's the standard size parabola. Now when the y equals 1/2 x squared comes in, it gets a little bit wider because it's been vertically shrunk. And then y equals 1/4, which is even smaller, causes the parabola to get even wider than the previous one. Does everybody see that? So y equals 1/2 x squared causes the parabola to shrink, a vertical shrink, by a factor of 1/2. Okay, and then of course y equals 1/4 x squared is the same thing, vertical shrink, but by a factor of 1/4. So the conjecture is multiplying the parent graph by a number whose absolute value is between 0 and 1, or less than 1 basically, causes the parent graph to shrink vertically. The colored calculators are more expensive. You'd have to buy one if you wanted a color one. They're just more expensive, and I mean, we don't really want to pay that money because look how often they get dropped. So. Finish this up, guys. We only got 7 minutes. Based on your conjectures above, sketch the graphs without using your graphing calculator. Okay, y equals x plus 3 squared minus 4. What does the x plus 3 inside parentheses do to the parabola? No, it moves it sideways, but which way? Left. Plus 3 is the opposite of what you would think. It's actually left 3. What does this minus 4 on the outside do to the parabola? Down 4. Okay, look guys, the inside number, the inside parenthesis number moves it left or right. Plus is left, minus is right. The outside number moves it up or down, and it is what you would think. Minus is down. So the parabola's vertex will move left 3, down 1, 2, 3, 4. Is this parabola going to open up or down? Up. There's no negative out in the front, so it opens up. Now, to get other points to know exactly how it opens, you would have to plug in x values, like plug in a -1, a -2, -3, and so on. But for now, since we already know how to do that, we know how to create a table and find the y values, we're just going to do a little rough sketch. Just open it up. Okay? All right, for number 9, what does this negative out in front do to the parabola? No. It makes it reflect upside down because it's negative. What does the plus 5 do? Up 5. So you're going to go up 1, 2, 3, 4, 5, and then it will open down because of the negative out in front. Okay, now we're going to write equations for the following transformations to y equals x squared. Remember, the parent function is y equals x squared. If you now want your parabola to translate 6 units up, what else do you need to put on this equation? A plus 6. Okay, for number 11, the parent function is y equals x squared. But to translate it right 2 units, what do you have to do? Parentheses before you square it, and what goes in there? Minus 2 will shift it right 2. Okay, number 12, to stretch it vertically by a factor of 3, what do you have to do to the parent function? Multiply it by 3. Correct. For number 13, this one has 3 different things it wants you to do to the parabola. Reflect it, move it 2 units left, and down 5 units. So how do you reflect it? A negative sign. How do you move it 2 units left? X plus 2 is opposite of what your common sense would tell you. And then how do you move it down 5? Minus 5. Okay, now turn to the next page so I can explain what your homework is. Don't worry, it's super easy. Okay, I want you to go ahead, like right beside the number, and draw a little vertical line on each problem. Okay, now the reason you're doing that is because for the homework, I only want you writing on this side of the line. Over here tomorrow, we're going to learn how to change from vertex form to standard form. This is what I want you to do for homework. I just want you to write the transformations that occur. What does this x plus 2 inside parentheses do to the parabola? Left 2. What does the plus 5 on the outside of the parentheses do to the parabola? Up 5. Remember, right and left shifts are the numbers inside parentheses. Up and down shifts are the numbers on the outside. So all you have to do is 2 through 5, write down all the transformations that occur. Look back through your notes if you're having trouble. You can switch out.